This is our Ecocolum. We named it Mr. Garrison's classroom, and named all the plants and animals after characters from South Park.
Our column consisted of two chambers. The first chamber was a terrestrial chamber with rocks, soil, one cover plant, and I think 2 crickets, but we lost the crickets, so they don't really count. It was connected to an aquatic chamber with one string that went into the water, and the water was treated so that it could sustain 2 minnows, and it had rocks on the bottom that sustained 5 elodiums.
We tested a variety of things in both sections of the ecocolum. In the terrestrial chamber, we tested for CO2 levels, percent of oxygen, temperature, and count of living plants. The oxygen stayed relatively constant throughout the entire tests. The temperature varied at the beginning during the first 2 tests, but we think that was because of the placement of the ecocolum. CO2 was a bit more interesting.
The variables for the aquatic chamber are dissolved oxygen, pH, life forms, and temperature.
Okay, so as Chris mentioned, the terrestrial CO2 looked a little bit interesting. It kind of oscillated, so it would increase, decrease over the course of the couple weeks. We think that this could be for a number of reasons. One of our hypotheses was that the rate of photosynthesis was changing as time went on, depending on the livelihood of the plant. We also think that this last it skyrocketed, and we think that that has to do with that when the plant died, not only did it release CO2, but it also stopped using the CO2 that was already in the environment.
After the experiment, we asked, does the temperature of the water affect the pH levels in the water? And our hypothesis was that as the temperature of the water increases, the pH decreases.
So this is a graph that shows temperature versus pH of the water. I know you can't really see it, but they are inversely correlated. So as the temperature decreases, the pH increases, and as the temperature increases, the pH decreases. However, this does not work vice versa. So as the pH increases, that does not mean the temperature decreases. It is a directional relationship.
We designed an experiment to test our hypothesis. We would get 3 beakers of water and measure the pH levels in each at room temperature. Then we would raise one by 2 degrees Fahrenheit, another by 4 degrees Fahrenheit, and leave the last one at room temperature, and leave them like this for 1 hour. After that, we would measure the pH in each beaker again and record our results. We would expect to see a negative correlation between pH and temperature. We'd expect the negative correlation between pH and temperature. Some things that we wouldn't really anticipate seeing in our experiment would be a positive correlation if the pH increased with the temperature, or if nothing changed at all. I think that's really short, really.